You know, when you hit play on a video, it just works. It feels instant, like magic, right? Well, it's not magic. It's one of the most massive and complex engineering systems on the entire planet. Today, we're going to pull back the curtain and follow the incredible, epic journey that every single video takes, from a creator's laptop all the way to your screen. To really wrap your head around how hard this is, you have to understand the scale. We are talking about over 2 billion logged-in users every single month. That's the real challenge here, engineering a system that can deliver a perfect, instantaneous experience for a population that massive, 24/7, without ever breaking a sweat.
So, here's our roadmap. We're going to follow the life of a single video through 5 crucial stages. First, how it's uploaded, its birth. Then, how it's prepared for every device on Earth. Next, we'll cover how it's delivered to you in milliseconds, then how YouTube's AI decides to recommend it, and finally, we'll look at the unseen foundation that keeps this whole thing from collapsing.
All right, let's start at the very beginning. Our story kicks off the exact moment a creator hits that upload button. The video file leaves their computer and starts its long journey into Google's gigantic global cloud.
As soon as it hits Google's network, it goes through this pipeline. But the absolute most brilliant part here is step 2. Chunking. Instead of sending one giant, fragile file, the video is broken up into tiny, manageable pieces. That's the secret sauce. It's why your upload doesn't just fail if your Wi-Fi flickers for a second. If one tiny piece fails, only that tiny piece gets resent. Plus, this lets other things, like virus scans, happen all at the same time, which makes the whole process way faster and a heck of a lot more reliable.
Okay, so the video is safely inside Google's network. Now the real heavy lifting begins. It has to be prepared for every single possible device and network connection in the entire world.
And this process is called transcoding. Honestly, the best way to think about it is like an army of digital chefs. They take one raw ingredient, that uploaded video file, and they prepare dozens of different versions of it. They'll make a grainy 144p version for a spotty mobile connection, a crisp 1080p version for your laptop, and a stunning 8K version for a fancy TV. It's this multi-bitrate ladder that makes sure the video just plays, no matter who or where you are.
Now here's the part that might surprise you. YouTube is not actually trying to give you perfect, flawless video quality. No way. That would be impossibly expensive. Their engineers are obsessed with a totally different problem: finding the absolute perfect balance between the quality that looks great to your eyes and the mind-boggling cost of storing and sending all that data across the globe.
And they don't just guess at this. They use hard data. They use a metric called VMath, which scores quality based on how we humans actually perceive it. Now, take a look at the standard 1080p tier. The goal isn't a perfect 100, is it? It's somewhere between 88 and 92. And why is that? Well, because for most people, our eyes literally can't tell the difference above that. But the savings in data from shaving off that tiny bit of imperceptible quality, at a global scale, it's absolutely enormous.
Okay, so our video is all prepped and ready in dozens of different formats. But how does it get from a data center somewhere to your phone, potentially on the other side of the world, in what feels like an instant?
Well, the magic here is something called the Google Global Cache, or GGC. Instead of pulling every video from a huge, distant data center, Google does something kind of sneaky. They put these small caching servers right inside your local internet provider's network. This means the videos that are popular in your town are actually stored locally, completely bypassing most of the traffic jams on the public internet.
And the impact of this is it's staggering. Get this, these GGC servers handle somewhere between 70 and 90% of all YouTube traffic. That means the video you're watching right now is probably coming from a server just a few miles from your house, not hundreds or thousands of miles away. This right here is the single biggest reason YouTube feels so incredibly fast.
But what about the millions of videos that aren't popular? Well, YouTube uses a really smart tiering system. Any brand new or viral video is kept on hot storage. We're talking super fast, super expensive drives for instant access. But that video from 10 years ago with only 50 views, that gets moved to cold storage, which is slower but much, much cheaper. It's a clever way to save a fortune while making sure the popular stuff is always snappy.
The final piece of this delivery puzzle is actually the player on your screen. It basically has a brain of its own, and it's called adaptive bitrate, or ABR. It is constantly monitoring your internet connection. If you walk into a different room and your Wi-Fi suddenly gets worse, it'll seamlessly switch to a lower quality stream before the video can stall.
Its absolute #1 priority is to avoid that dreaded buffering wheel, and it will sacrifice quality in a heartbeat to keep the video playing.
So, the video plays smoothly. But how did you even find it in the first place? All right, let's get into the most famous and maybe the most mysterious part of the whole system, the recommendation AI.
I mean, really just think about this question for a second. With hundreds of hours of video being uploaded every single minute, how in the world does the system sift through that endless ocean of content to find the one thing you'll probably want to watch next?
Well, trying to look at everything at once is impossible, so it uses a clever two-stage funnel. The first stage, candidate generation, is like a massive wide net. It takes billions of videos and quickly narrows them down to just a few hundred possibilities. Then, the second stage, ranking, takes that much smaller list and meticulously scores each one to find the perfect match for you at this exact moment.
So that first stage, candidate generation, is all about speed and breadth. It uses these really complex AI models to create a sort of digital fingerprint for your viewing habits, and another one for every video. Its job is just to find all the videos whose fingerprints are a potential match for yours. Its goal is what engineers call recall. Just don't miss anything that could be good.
Then comes the ranking stage. This is a much more powerful and much more expensive AI. It looks at hundreds of different signals for each of those few hundred videos, and it asks one key question. How long are you likely to watch this? Its primary goal is to predict expected watch time. See, it's not just about getting you to click. It's about finding a video that will actually hold your attention.
And this represents a huge philosophical shift. Early on, the system was really just optimized for clicks, but now it's all about satisfaction. By focusing on valued watch time, not just how long you watch, but also if you like it, share it, or engage with it, the system is aiming for long-term happiness, not just a cheap click. And finally, none of this would work without an incredibly solid foundation. So let's take a look at the core principles that keep this massive machine running around the clock, day in and day out.
The entire system runs on something called Borg, which is Google's legendary internal cluster manager. You can think of it as the master conductor for a global orchestra of computers. It's the system that's assigning every single task we've talked about, from transcoding a video to training an AI model to the right server at exactly the right time.
So how do they keep it all reliable? With a data-driven framework called Site Reliability Engineering. It's pretty simple in concept. First, you define what good looks like with a specific metric, your SLI, something like playback latency. Then, you set an aggressive target, your SLO. For example, 99.99% of videos must start in under 300 milliseconds. And finally, you attach a real consequence if you miss that target. This disciplined, data-first approach is how you maintain excellence at such a massive scale.
And it's really important to remember that this video journey we followed is just one piece of a much larger puzzle. Systems for search, live streams, and ads are all their own massive undertakings, but they're all running on the same shared foundation. This creates this incredibly efficient ecosystem, where an improvement to one part of the system can actually make the entire platform better.
So from a simple upload to a globally delivered AI-recommended stream, that is the epic journey of a YouTube video. It leaves us with a pretty fascinating thought to end on, doesn't it? As these recommendation systems get more and more accurate at predicting what we want, where's the line between simply reflecting our tastes and actively starting to shape them?